let's close out this week by talking about refactoring our code and just a couple of common code smells and how we might go about fixing them. And then at the end, I'll have a little exercise for all of you to do on your own and with your groups. So I've talked about this word before, but I'm not sure I've ever actually officially given it a definition. So I'm going to do that now. What is refactoring? It's this idea that we're changing implementation, but not the functionality. So now we have that written down somewhere, right? And we do it for readability, extendability, flexibility, all the abilities, right? That's why we want to refactor our code so that it's clean, clear, concise, and cool. I'm trying to think of all the alliteration I can get in there too. Back when we did TDD, we had red, green, refactor. While a similar style loop might work, when we're not doing test-driven development, we might want to consider doing something different with our refactoring cycle. We're going to do green, refactor, green. When we do green, refactor, green, we ensure that all of our tests are working as we expect. We refactor our code, and then we ensure that all of our tests are still working as we expect. So if we have the faith in our test suite that we know that it's comprehensive and that it's sort of going to encompass and cover all the cases we really want to be covering after a refactor, we shouldn't have broken anything. So we're going to go through a bunch of code smells here with some examples. So what is it? A long method is a method that tries to do too much, right? It makes it hard to understand it, to test it, and to maintain it. So it's hard to read it or understand it quickly. Most of the time that means it doesn't have a very good method name, and we all know how well we all comment, right? It makes it a lot harder to reuse logic, because that logic is going to be interspersed around everything. And it's a lot more prone to bugs when it gets modified, because it's possible that we change something that was being relied on higher up or lower down, and we can't tell because of just how big of a method it is. So let's start with this code here for I'm too long, and I've created this method interactive data maths. So we can see here that we're going to collect some information from the user. We collect their name, we collect their age, which we then parse. We get their favorite word, their city, a list of numbers from them. We then want to search for a target number in the list that they previously gave us, and another status, another sentence, pardon me, that we're going to use for some stats later on. We then process all of that information. We get the medians, we get some average values, minimum, maximum. We also get the mode in a really terrible way. We get a frequency map of all of the numbers, right? And then we can also get the string stats here as well. All similar kinds of how many vowels, consonants, digits, etc. We can find the occurrence of a given substring, right? Find substring occurrences of favorite word inside of a bio or something. We've got building out a histogram with the keys and so on and so forth. And then we print it all, right? We're going to print all that information out that they gave us that we calculated, print our top three, and then some more summary that actually has some copy over. Okay. If you want to try this, it'll be uploaded. You can. You'll see that it works, but it's giant. So I will leave it to all of you to now make this not so giant. I have left some comments in here that will hopefully help you understand how you might want to start pulling things apart. But again, anytime we start to pull something apart, we run it, we pull it apart, we run it again. You don't need to make all of the refactoring changes at the same time. Small and steady changes, right? We want to make sure we don't break everything while we're doing this. So we break it into smaller focused methods that do a single thing, and this is known as our extract method refactoring. The next one that you might see is data clumps. This one's really, really common in these projects. It's basically a group of variables. Often they end up being parameters that you pass around that we frequently find together. And anytime we see that we have a group of variables that are frequently found together, there's a good chance it should actually be an object, even if it doesn't always make tons of sense for it to be an object, because we are used to objects being a thing, an actual tangible thing, a user, I can only think of user recipe, a ingredient list. We're so used to whatever that category is of objects, that's what we're used to making into objects. I'm hoping that now, since we talked about single responsibility, that that these object classes can be anything. We can make an output formatter, an area calculator. And so when we have a data clump, it's possible that we can turn that into some kind of contextually significant object, even if it doesn't represent, say, a database table, right? It doesn't have to directly match a database table. Let's take a look at what that might mean. So here I have this this class here, we should clump some data. So here we can see that we're checking to see if a start date, a probation date, and today, so we have these 3 dates, and we're just checking to see if somebody's off probation, right? So we know when they started their work, we can see when the probation end date is, we can make sure that they're set, we can check what today is, and then we can make sure that today is not before when they were supposed to be done, right? So they've started, they actually work at the company, the probation date has been set, etc. We also want to check potentially if a company is eligible for benefits. So we've got our start date, our probation date, and today, and then the minimum number of months for benefits. And we may need all of these pieces of data, right? We need the months at the company. We need to ensure that they've passed their probationary period, and we need to make sure that they have been there for long enough. The next check for a company like scenario is if somebody is promotable. So again, we need that lots of information here, right? Some of this comes from like previous methods or calculations, and we can see that we want to see if they have the performance rating required in addition to their project's completion, that their probation is over. All that good stuff. We've also got like accruing part-time off days or personal time off days. We've got if they're eligible for stock, if they should get a retention bonus. And then we've got all of the checks happening here based on those pieces of data. Now, we don't have like a name or an employee ID or anything like that. But what we can do is introduce an object like an employment timeline or maybe an employment context that can hold a lot of this information rather than putting all of it into a service layer or putting it all into, employment validator, right? We will very frequently try to lean toward an employment validator in this type of situation, but really it could just be an object. And then the user could have, like a user object could have an employment timeline object or an employment context object, right? So really trying to think about like composition there. Okay, so it's a problem, right? We ended up with lots of duplication and inconsistencies, and our method signatures got very bloated and confusing. So like we said, we can encapsulate those data in a class or in some kind of a record and be able to use them then as a clump of data that we pass around. All right, next is this idea of shotgun surgery. This is when we make a small change in our code and it forces us, or we make a small change like in our requirements or our scope, whatever. And now we have to edit our code in thousands of places, right? Like we have to just make a bunch of changes to our code. This increases the risks of bugs and it makes refactoring so painful that we just like don't want to do it. So, and this you'll see like in industry code all the time too. So for example, let's take a look at my chain reactions code here. Let's pretend that we here are working through, a company that has its employees and we're calculating weekly pay. We've got a little bit of an employee object here. We have a work entry object. We know there's payroll service, timesheet service, all these different services. They'd all live, in different places, but they all exist. And then we realized that when this was all set up, intern actually was the wrong word. We don't use interns. We have co-ops. Okay, we don't have interns. We have co-ops. Or somebody was entering in the data as an intern and somebody else started entering it as co-ops. So now I need to go change it. Okay, intern. I can change intern to co-op. I can change intern to co-op. I can change intern to co-op. Now, right now across a single file, maybe it's not the end of the world, but it's possible that there are so many of these across so many different files that we have to make a bunch of changes, right? This is only 18. It's a small example, but we can see how it can start to get kind of unruly just by a very, very small change, such as just like a naming change. But what happens if like a rule has to change as well, right? Like what if this has that interns, they get a stipend if they've worked greater than 20 hours in a week. And it looks like this is also happening in reporting services. So thank goodness for my comment, right? So that I can know that that's where it is. But people generally don't leave those comments behind, right? So we can see it right there. And if I told you that that comment didn't exist, you came into the code base and you were told that interns who work more than 20 hours a week actually are now getting a stipend of $500. You would probably go into here and go, okay, I'm going to calculate the weekly pay. Interns Working more than 200, 500. Okay, done. Without even thinking about the fact that it might be somewhere else in our code, right? Living somewhere else, now causing a problem, having expense caps being potentially different, right? So it's really important that, that when we're dealing with these sort of chain reaction scenarios, that we catch them as early as we can to avoid a lot of errors. So let's take a look. How are we actually going to do this? We're going to improve our cohesion. Instead of having it all living in different places, if we realize that we're repeating code, repeating logic, we need to ask ourselves, do we need another class? Do we need to move this somewhere else? Do we need to group our data differently? We really want to be able to localize our changes to one place. If this had been set up in a multi-tier, like a multi-package project, I would have been making changes across actually multiple packages potentially as well. The next one is called feature envy. This is when a method in a class seems overly interested in the data or the behavior of another class. And a lot of these can really be tied back into our solid principles. So if you're sort of saying, oh, well, a lot of these sound like, the single responsibility principle is being violated. Absolutely, right? This is just sort of another layer on top of the solid principles. So this is a huge problem because it violates encapsulation. It indicates that a method might belong in a different class. If you need all of that data to run this method appropriately, maybe it shouldn't be inside the class that it's in. Let's take a look. Over here, the warehouse is going to get real jealous. So we've got 3 classes here, an address class, a line item class, and an order class. And of course, these should be private and appropriately set up. But for right now, these are just meant to be like our dummy classes, because what I really want us to focus in on here is the fact that the warehouse is going to estimate shipping, right? They get all the line items together to compute the weight. They get the package that they have put together like boxed everything up, and then they need to figure out the billable weight. They map out where the destination is based on the address, and then depending on where the city is from, it's going like how far away it is or whatever it might be. There may be a surcharge, and now it can actually get like the warehouse can give you the actual price. We can see so many different solid violations in here, but absolutely there's a lot of poking around happening in here that really shouldn't be. Now, a term that I haven't actually used here, but maybe you learned in a previous course, is the law of Demeter, or the principle of least knowledge. Anytime you find yourself doing this, multiple chaining of methods or properties or fields, whatever it might be, anytime we have this happening, we are doing something wrong. This tells us that this is living in the wrong spot. This is not in the correct level of responsibility. When we talk about design patterns in the coming weeks that we can sort of employ, we're going to talk more about the chain of responsibility and strategy patterns and how to deal with this situation. But we can really sort of hone in on anytime we're chaining these dot notations together. This is a law of Demeter violation, also known as the principle of least knowledge violation, and that's a problem. So that is right in line with feature envy, and this needs to be addressed. So what do? We're going to move the method to the class that it's most interested in. If it's very interested in a class, there's a good chance that's where it should live. This is also known as move method refactoring. So if we look here and we're trying to figure out a destination, why does this live inside the warehouse? It looks like order ship to postal code. It looks like it's really quite interested in the postal code, which comes from this ship to, which is inside of the order. So first thing I would do is I would pick all of this up, all the stuff that has to do with the zones and mapping the destination, and I'd put it in the order. And once it was inside the order method, I would then realize that I'm still doing a ship to dot postal code. And that would make me realize order isn't deep enough. I actually should pick it up and put it into the address method. And I would pick up all that stuff and put it in address. So now the warehouse would ask the order for this information, and the order would retrieve it from the address. And then the address does the actual calculation. So yes, we're very frequently in our class right now focused on what are called anemic data models. So we do end up with some of this chaining occurring a little bit more than maybe we want to. But we can see how we can start to sort of expand our horizons on what a data object might house within it so that we can make some smarter choices about where things are living and keeping each of these classes sort of really well encapsulated within its own need to know behaviors and fields. All right, the last one I'm going to show, I have two more here, but the last one I actually have code to show with is the switch statements over types. So common. This is when we have a switch or an if-else chain that's based on strings or enums or integers or clicks, whatever it might be to decide behaviors. And as we know, I've said it before, this violates the open close principle. We have to fix this. This is not okay. And this often means that we have logic scattered across our code base. If one thing is true, go over here to handle it. If this one is true, go over here to handle it. If this is true, go over here to handle it. And it ends up kind of all over the place. Whoops. If this is true, go over here to handle it. And it ends up kind of all over the place. So here we have an example of this for the old switcheroo. We have some different payment types as an enum. And then depending on the right one, we're calculating our fee. We're generating different receipts depending on how it was paid for. And we're determining whether or not it's going to be refundable. Now we can see that we have three different if-else statements. We only need one of these methods to tell us that we're violating the open close principle, but a slightly bigger example might be helpful, so I included three here. Now it's also worth noting that for this one, I'm actually going to show you how we make it better, because this is easily one of the most common issues I see in 3350 project code bases. So when you find yourself using these if-elses or multiple ifs or the switch case statements, what exactly can we do? Yes, this code is including white spaces and lines that only have brackets on it, 39 lines of code. And yes, this one here I'm going to show you got longer. It's going to be 50 lines of code, although this also has a main, to be fair. What are we actually doing different? I've set up an entire ecosystem around payments. I have an interface for the payment method that now will calculate the fee, generate the receipt, and is refundable. So all three of these methods have now become encapsulated within an interface. And each of these data types that were enums before are now no longer enums, no longer strings, no longer integers. They now live as classes. So we have a credit card payment, we have a PayPal payment, and we have a bank transfer payment. And each of these have their own information associated with them as well. Now there's a good chance I would probably also be making like a static string, static final string format paid variable that would start off like this: paid $% %d 0.2. So then that way I could actually pick up this here in each of them and not use it. So I could do string.format. It actually is final, so it should be like format paid. I would do something like this: string.format format paid, comma amount, and then I could concatenate this last little bit on. So then that way, if for some reason at a later point in time, the $sign needs to change to a pounds, like European pounds, right? Like a British pound or francs or whatever, I wouldn't have to change it in a bunch of places. So that is something else that I would probably have centralized in my payment method, to be honest. Pretty minor additional change, makes a really big difference in the code as well. And then of course within each of these classes you could put like final variables for each of these and all that good stuff, right? And then we can see that we actually, in addition to each of these classes, is we have a payment registry class. Now again, this is a pattern that we're going to learn a little bit more about next week, but if we go back to the old switcheroo, it's pretty obvious here that we have these payment types, which means that if there was like some kind of a main, we'd want to be able to map what a user might enter as their payment type to these different like payment types, to these different classes. So we have a registry here where what we're actually going to do is we are going to register each, oh, here it is, whoops, each of those different data types, card, PayPal, and bank, as a object type, a credit card payment, a PayPal payment, and a bank transfer payment. So now we can make our new registry. We register all the different types of payment that are possible. And when we need to use a payment method, we can just grab it. So a registry, it does no longer violates this open close principle, because previously when we got the type from the user, we still had to figure out, do we want to make a bank transfer payment, a PayPal payment, or a credit card payment object? This way we don't have to do that switch statement anymore. We get to use hash maps. Our hash map is really efficient. It's really tidy to look at, and we can get all of our information really, really cleanly. So I'm going to upload all of this as well so that you also have access to this code too. Okay, so like I said, we're going to use polymorphism to fix it. We replace that switch statement with methods and subclasses, or even like a strategy pattern, as we saw in registries. Now, the last one I don't really have an example of right now because it is all of the things we've already seen, which is God classes. This is a class that knows too much or does too much, and it often is just becomes a dumping ground for unrelated logic. I do see it sometimes, not as much, but I do see it sometimes as like a utility class or like a general validator class, right? Where we kind of shy away from wanting to make classes that might be small. Right? Oh, we have one for validating string related stuff or one for validating integer related stuff. Well, we don't want to do that. Those will be really tiny. Let's just make a validator class, right? But then we end up with these dumping grounds. So we end up with really high complexity and low cohesion, as well as this random God class being tightly coupled with everything. Everybody relies on this one random God class, and that's a huge problem too. So just like we saw with our long methods, just like we've seen with single responsibility principle, we need to break it up into smaller, well-focused classes, each with their own responsibility. That's way more important than not having enough classes. So anytime you see code that, sort of might rub you the wrong way, you think might smell a little funny, ask yourself, why did you write it this way? And if it's, I don't know, or I was just getting it out really quick, like those aren't valid, defensible reasons, right? There's a good chance you're falling into some kind of refactoring trap here, and we've got a little bit of work to do. So we can see that single responsibility principle can help us remember to split logic. Open close principle can help us to eliminate those giant switch case situations and implement those patterns. Dependency injection principle, oh my God, I just did it. Dependency inversion principle can help us reduce any sort of tight coupling between high and low level modules. Think about the other two here that I haven't mentioned, list cross substitution and interface segregation principle, and ask yourself, how could you use those principles to minimize some of the other smells that we may be leaving behind? The last thing I'm going to have you, I hope, do is you'll sit down and actually practice identifying and understanding some of these common code smells. So while I did upload code for each of these, I didn't fix them yet. So feel free to go and fix them. But also spend a little bit of time of creating short examples of your own that sort of show off each of these code smells. Try to keep your examples between 10 and 30 lines of code. That's more than enough to show off each example. It doesn't even need to compile. We just want to show the smell. If it compiles, that's a bonus. Name each one, smell 1, smell 2, smell 3, etc. And then in your next group meeting, take turns showing your teammates each other's, or maybe everybody passes one of their files to somebody else. See if you can determine what smell the other person coded up, and have a really good discussion about how you all might go about fixing those problems. With that, we're all done one of my favorite weeks. That makes me kind of sad because I love all of this topic, but there's still good stuff to come. We've covered a bunch of different design principles, lots and lots of acronyms, some ways to refactor. It's a very, very information heavy week. So take some time to sort of sit back, review it, get a good handle on it, and I will see you in the next video. Thanks, everybody. Bye.